So the title for this one is Without Git, You're Blind. And you know what? That's not an exaggeration at all. Today, we're really going to see why this tool is as essential as, well, oxygen for any modern software team.
All right, team, listen up. The alert just fired, PagerDuty is a sea of red, the app is completely down, and I've got VPs pinging me on Slack. Yep, we're in a classic all-hands-on-deck crisis. So, just take a breath. The most important question right now is, where do we even begin?
You know, the first rule of handling an incident like this is actually pretty simple. You can't fix what you can't see. Right now, we're basically operating in the dark, totally lost. To figure this out, we need to turn on the lights. And for us, those lights are a complete, unchangeable history of every single thing that has changed in our system.
Okay, so our investigation starts right now. And look, we're not just hunting for a bug, we're building a timeline. What changed? When did it change? And honestly, the most important question we have to answer is why did it change? We got to follow this digital trail all the way to the root cause.
So that digital trail, it comes from our version control system, or VCS. For us, and pretty much for the rest of the world, that means Git. It's literally a time machine for our code. It records every single change to every file forever. During a crisis like this, Git isn't just some tool for developers. It is our #1 investigation tool. It's how we turn on the lights.
And this right here, this is our source of truth, the Git log. Every single one of these lines represents a change. It tells us exactly who made it, the precise time they made it, and if they did their job right, the commit message tells us why they made it. No more guesswork, no more, I think I might have changed something. That why can be the difference between a 10-minute fix and a 10-hour headache. This is always our first stop.
Now, just try to imagine for a second doing this without Git. It would be absolute chaos. You'd be frantically pinging people on Slack, asking, hey, did you deploy anything last night? People forget, right? Files get overwritten. As one of our sources points out, without a commit mechanism, you're just flying blind. You have no clue who changed what. With Git, we have an immutable audit trail. It's all there.
Okay, so using that Git log, we're zeroing in on the problem commit. But that kind of brings up a bigger question, doesn't it? How did this bad change even get into our system in the first place? I mean, with dozens of developers all working on the same code, how do we stop them from constantly stepping on each other's toes? It's all about taming that complexity.
So over on the left, that's the old way, pure chaos. Multiple people editing the exact same files, a constant mess of overwritten work. It's a nightmare. But on the right, that's the control that Git gives us. Every developer, every new feature, every single bug fix lives in its own isolated branch. Think of it like a parallel universe where you can work safely without messing up what anyone else is doing.
This whole process is what we call the feature branch workflow, and it's our standard playbook. Step 1, you create a new branch from the stable main codebase. Step 2, you do all your work there. Step 3, and this is absolutely the most critical part, you test your changes in isolation. This branch is your own personal sandbox. You can go wild, try crazy ideas. If they don't work, you just delete the branch. No harm, no foul. And only when you're 100% sure it works do you get to step 4, merging it back into the main branch. This workflow is our first and most powerful line of defense.
Look, finding and fixing this outage is obviously critical, but it's all reactive. We're just putting out fires. And we really don't want to be here again next week, right? The real goal, the whole philosophy behind DevOps really, is to be proactive. We need to build a system that prevents these issues from ever even reaching production. And the foundation for that entire system? It's Git. It all boils down to a really simple daily ritual. These 3 commands, they are the heartbeat of our whole development process. First, you git add to tell Git which changes you want to save. Then you git commit to package them up with a super clear message explaining what you did. And finally, you git push to share those changes with the rest of the team. This disciplined process is the absolute bedrock of a stable system. And this is where the real magic happens. The moment a developer runs git push, it's not just sharing code. It's like kicking off an army of robots. Our continuous integration, our CI pipeline, it instantly wakes up. It automatically grabs the new code, runs thousands of tests, and tries to build the entire application. If even one of those steps fails, the change is automatically rejected. The team gets notified immediately. If a check like this had been in place, the bug causing our current mess, it probably never would have made it through. This automated safety net is how we stay confident that our main branch is always in a good state.
Now, so far, we've been talking about our application code. The Python, the Java files. But this whole discipline of tracking changes, collaborating safely, automating everything, it applies to so much more than just the application itself.
And that really brings us to the final and maybe the most important question of all. We are so disciplined about versioning our application code, but what about the very infrastructure that it runs on? I'm talking server configurations, network rules, database schemas. Are we just SSHing into a server and changing that stuff by hand, crossing our fingers? Or are we treating it as code, storing it in Git, where every single change can be tracked, reviewed, and validated? Because if we're not, well, then we're still operating with a massive blind spot. And I guarantee you, in that blind spot is where the next major outage is just waiting to happen. And that's the thought I'll leave you with.